Please join me in welcoming our first speaker, Tom Stellar, who is from AMD and will talk about LLVM stable releases.
Okay, I can have it here. All right, great. Well, thank you. So like you said, my name is Tom Stellar. I'm a software engineer at AMD. And today I'm just going to talk a little bit about stable releases in LLVM. So first I'm going to talk a little bit about why we decided to start doing stable releases in the project. And I'll go through sort of a simple use case of one of the open source projects that really depends a lot on these stable releases. Go through a little bit of the stable release history, and then go through the process, what we're doing now, areas for improvement, and also ways that people can get involved if they're interested in helping. Okay, so why stable releases? So really the number one reason is just to make life easier for LLVM users, no matter how they're using LLVM. So there's a lot of different projects and a lot of different users out there who use LLVM for a lot of different things, and a lot of times they're standardizing on a particular release. So maybe we'll release 3.5, they'll take that, import it into their project, stabilize against it, and continue the development of their project. So in doing that, they are always going to have to backport bug fixes and other things. So if you have a lot of different projects doing this, it's kind of a lot of duplicated effort. So if we as a project can create sort of a centralized repository for doing all of the, there's a single repository for all the stable fixes that everyone can share, it saves a lot of work for a lot of people. Another advantage of doing it this way is the official stable branch has input from LLVM developers. It goes through our testing regime. So these projects can sort of have an assurance that the patches they're backporting aren't breaking things, and that it's generally a higher quality release than maybe what they're able to do with the limited resources some of the projects have. So another advantage of doing the stable releases is it really helps to shorten and stabilize the release process for our major releases. The reason for that is we sort of have an out, so if there's a last minute bug that's found, maybe it's low importance, we don't have to hold up the entire major release and go through a whole nother cycle. We can push it off to the next stable release and then go ahead with the major release as planned. Another great thing about the stable releases is it allows us to get better testing coverage. So typically once a version of LLVM is released, it starts to get packaged by Linux distributions. Other people start to play with it a lot more than people who are actually just using tip of tree from SVN. So this gets LLVM into the hand of more users, gets more testing, and then we can get bug reports and respond to those in our stable releases. So it's a good thing for us there too. And the other nice thing is it helps to keep projects involved in LLVM. So if someone, for example, is stabilizing against LLVM 3.5 and they find a bug, now they have an avenue to contribute it back to the community. Of course, they can always contribute it back to top of tree, but it's possible that maybe the project, they don't have the resources to test against 3.5 and tip of tree for whatever reason. So having a stable branch they can contribute a bug fix back to sort of helps keep them involved in the project if they aren't able to always be tracking tip of tree. So it's kind of a nice thing. All right, and so like I said before, who's benefiting from stable releases? We have the operating system distributors. They're responsible for maintaining packages, making sure that if their users find a bug, that they get the bug fix into their package. So again, having a single stable branch for all of them to pull from just makes their life easier. Also, open source projects, any project that itself depends on distributions packaging their code and distributing it to users, they really can't take their own snapshot of LLVM and distribute it with their project. They're sort of, they're not really stuck, but they just need to use whatever comes on the system. So if they have an avenue for getting bug fixes into the system version of LLVM that's distributed by their operating system, then that's a good thing, and that really helps their projects. And again, this isn't only beneficial to open source projects, but pretty much anyone who's using LLVM. It just makes life easier if you can stabilize against a version and you know that there's a stable release out there that other people are contributing fixes to, it's being tested. So lots of benefits for lots of different people. Okay, so I'm just going to go really quickly through a use case for the stable releases for the open source Mesa 3D project. So what Mesa 3D is, it's a open source GPU driver project, and it has lots of different GPU drivers for different kinds of hardware, sort of at varying levels of completeness. So sort of at the more complete level, you have the AMD and Intel drivers, which actually have teams of paid developers who are working on them, have a lot of features and work really well. And then there's other drivers in Mesa that are reverse engineer projects. For example, the NVIDIA driver. There's a free Adreno driver for Adreno GPUs. So those are, those take a little longer to develop. But so sort of a wide variety of drivers in this project. Mesa is on a 3-month release cycle, so new features are coming in and new releases are coming out really fast. So it's a little different than LLVM, which is on a 6-month release cycle. And like I mentioned before, it's an open source project that depends on the release packages that come from the distribution. So it's not shipping its own copy of LLVM, it's relying on whatever comes from the system. So within Mesa, there's actually 3 different drivers that use LLVM. The first one is something called LLVM pipe. And what LLVM pipe is a software rasterizer. So basically how it works is, so in Mesa, one of the APIs that's supported is OpenGL. So if you run your OpenGL program, instead of having GPU acceleration, it just executes everything on the CPU, and all the OpenGL functionality is implemented in software. Now where LLVM comes in is in OpenGL, we have this concept of shaders. So basically what that is, it's a piece of code that you can run directly on the GPU. And what it's used for a lot of things, but sort of the simplest is basically just calculating the color for 1 pixel on the screen. So you might have an input of the location. You can have other inputs like lighting, and then use all that information. You run a little program, and you calculate what color the pixel should be. So what LLVM pipe does with these shaders is it just uses LLVM and compiles it directly to x86 using the JIT compiler that's part of LLVM, and then runs that code right on the CPU. The other drivers that use LLVM are the AMD drivers. So those cover everything from Evergreen GPUs all the way up through AMD's latest Sea Island GPUs. And that has a little bit different usage model for LLVM, which I'll get into next. So as I mentioned before, LLVM pipe, it's completely in software. It does all its OpenGL implementation on the CPU. So the driver features, so in LLVM pipe, the driver features and the compiler features, they're completely separate. So if you add a new feature to the driver, you really don't need to update anything in the x86 backend, because all you're doing is giving it just standard LLVM IR for the backend to compile. So the biggest challenge with LLVM pipe is if there's a bug or something that causes us to disable an optimization pass, or maybe we have to make some other workaround in our code, maybe with how we generate LLVM. These are the sort of the issues we run into with LLVM pipe mostly. So sort of the main thing that LLVM pipe needs is just a way to, if we find a bug, contribute it and have a stable release that's being distributed by different Linux distributions. So the difference with the AMD drivers is there's a much tighter integration between the driver and the compiler features. So if let's say, for example, I add a new OpenGL feature to the driver, there might be some associated compiler changes, so those are going to be tightly coupled. So because of that, if a new feature goes in sort of at the end of an LLVM release, we rely a lot on community testing and things like that, so we don't always catch bugs right away. So in that situation, with something going in at the end of the release, if a bug comes up and there's no stable releases, well, now we have to wait 6 months until we can get a bug fix for our project, which really isn't a good solution for us. So we really needed to come up with a solution for getting bug fixes into the distribution packages and faster than 6 months. So the first idea we had in Mesa is to just take the bug fix patches that we need and send it directly to package maintainers. So send it to the Debian package, send the patches to the Fedora package maintainers, things like that. It turned out this wasn't really the best solution. We thought it would be maybe a little easier than it was, but it's hard to track down all the different package distributors and all the different package maintainers, and you're not going to be able to cover all the different distros because there's some that are less used. So it's just a lot of work. And another problem that ended up happening was we actually broke the Ubuntu package for Clang 3.2. One of the bug fixes that we had submitted added a new intrinsic, and what happens is because the intrinsic table is generated by TableGen, if you add a new intrinsic, the table is sorted alphabetically, so that new intrinsic gets added right in the middle of the table, and so it shifts all the offsets in the table and breaks the ABI. So that's what happened. We broke the LLVM ABI, and then Clang was broken. So a lot of work and really not very good results. So we really needed to come up with something that was a little different. Okay, so our first attempt at actually doing a stable release within LLVM was for the 3.3 series. It wasn't successful. We weren't actually able to do a release. And the main reason for this was there really weren't enough testers. There weren't enough people interested in the community and doing the testing to get a release out. Also, it was a little unclear exactly what the qualifications were, what hardware we needed to test on, things of that nature. So, like I said, weren't able to get it out. However, there are some positives that came out from this. Excuse me. For example, we added an extra number to the LLVM version, which may sound easy, but it's actually really difficult. So we had to do a lot of changes. The release scripts, all the different build systems. We had to test it with different projects that use LLVM. There's a lot of work that went into that. So that was one of the positives that came out. Also, there are some release script improvements that were done, mostly around handling the extra version number. So that was a good thing. And the other thing, I think it helped sort of raise interest in stable releases because we're talking about it on the mailing list. Maybe people start thinking about it and say, oh, yeah, that's a good idea. Maybe that's something I want to help with or I want to get involved with. So that led us to the very first stable release that we did, which was 3.4.x. This was actually successful. We had two different stable releases, 3.4.1 and 3.4.2. Some of the challenges with this release were, again, dealing with the extra number in the LLVM version. So even though we had added it, there's still some bugs that we had to work out with that, especially around the way that we tag the release candidates in SVN. So we had to adjust our naming scheme a little bit just to make the release scripts a little more simple. Another challenge was, so I sent out a release schedule. We have all this plan, and it seemed like the last 2 days of the schedule, everyone wanted their fixes to merge in. So I have like 20 or 25 fixes trying to get in at the last minute, so that was kind of a challenge. Also, we had a rookie release manager. It was my first release, so there's a lot of sort of kinks to work out with that. And the other big thing was 3.4 was the last release that did not allow C++11. So as we're backporting fixes, we had to be really careful about not including any C++11 code. So that was something that made it a little more difficult. So the 3.4.1 release, it just had fixes, a lot of just bug fixes all over the place, lots of fixes in the targets, a couple core fixes, some C++11 fixes as well. So there were a lot of changes. The 3.4.2 release was quite small, but there were actually a couple of really important fixes. For example, a build fix with GCC 4.9, so this was kind of an important thing to get in there. And actually, GCC 4.9 was released after 3.4, so there wasn't really a lot of testing going into building LLVM with GCC 4.9 during the regular release process. So because we had stable releases, we're able to support this new version of GCC, and this is what distros are packaging in the future. So it really will make life a lot easier for our users, where and also the Linux distributions, because they aren't going to have to carry around a patch version just to support GCC 4.9. Another important fix we had was we're using the wrong shared object name in the shared library. So what we were doing was we have so how it works is with the shared objects we produce a lib-LLVM-3.4 shared object, but then we also have a symlink to LLVM 3.4.1, 3.4.2, 3.4.0, whatever it is. So we're actually using 3.4.0, 3.4.1 as the shared object name in the main shared object, which breaks things for a lot of distributions because they depend on that name staying the same when they're linking against packages and they're upgrading LLVM to the next stable release. So that was something that was caught by, I forget exactly who, it might have been the Debian maintainers, so we were able to get that fixed in there. And that's actually something that's really good because we can carry that forward into tip of tree and all the rest of the releases. So the next planned stable release will be 3.5.x. There hasn't been an announcement yet, but probably will be sometime in November. Like I said before, we have our new SVN naming conventions in place. So we sort of had to retrofit 3.4 to use the new naming convention. So we actually did use this new convention for 3.5.0, and I think this will make the release process just a lot smoother. So it's something I'm kind of excited about. The other change that we've made is with the 3.5.0, we started a new policy of allowing developers to actually merge their own fixes into the stable branch rather than having the release manager do it. And I'm not sure historically if this has been done before, but it seems like in the last 2 or 3 releases, it's been just the release manager doing this. So there's some pluses and minuses to this, which I'll talk about later, but I think overall it's a good change and sort of makes less work, especially for the release manager, which is nice. Okay, so here's just a brief overview of the stable release process. So how it works is a community member, which can be anyone, it can be a developer, a user, it doesn't really matter, can nominate a patch to be merged into the stable branch. And the rules for that patch are it must be approved by the code owner, it must be approved by the release manager, and in most cases it should have already been merged into tip of tree. Now there's going to be some situations where maybe a bug pops up in the stable branch that isn't in tip of tree, but really, if there's a bug in tip of tree, it needs to first be fixed there, and then the fix needs to be backported to the stable branch. Another rule, and this rule is actually different from a regular like 3.5.0 release, is that the patches can't break the shared library ABI. So what that means is if I have an application and I build it against LLVM 3.4.0, I have to be able to swap out any of the other stable release versions. So whether it's 3.4.1, 3.4.2, I can just swap in the updated shared object and everything will work. And so once a patch has been approved and once it's been determined to meet all these requirements, the release manager or the developer now is able to merge the patch into the stable branch. So it's not a perfect process. We have some challenges. One of the main challenges that hasn't really been an issue yet, but I can sort of see it popping up is determining the difference between a bug and a feature. Typically for the stable releases, we just want to include bug fixes. But oftentimes there's sort of a fine line between what's a bug and what's a feature. Maybe there's a missing command line option. Well, okay, is that a bug? Is that a feature? You know, it's hard to say. So that's a challenge. I think typically, you know, if it's something that's going into a backend and it's sort of a target-specific change, there's a little more leeway into what's allowed. But definitely, if it's something in LLVM core, you know, it really has to be a bug fix. Another challenge is testing for ABI compatibility. So I found a tool for doing this, and it worked okay, but it seems to have a little bit of trouble with new versions of GCC. And there are actually some false positives with the 3.4 series. So it wasn't perfect, but it seemed to work. So I'm sort of looking into other tools and see if there's anything else out there. And you know, obviously, if anyone has a suggestion, that would be great for me to look at. So I mentioned this before the 3.4 release, but sort of the ongoing challenge is merge requests that come in the last minute. And there's not really a good way to deal with this. I think the best way is probably to help developers and users get in the habit of when they fix a bug, you know, evaluate it. Is this something that I can port back? And if it is, you know, then right away send an email, notify the release manager, and get it ported back as soon as possible. Another challenge is that the merge process can actually be kind of difficult. Usually when we create a release branch, you know, everyone wants to then add their new features, do a lot of refactoring into tip of tree. So sometimes it makes the merges back to the stable branch a little more difficult. So, you know, that's something, again, not really a perfect solution for it, but I think having developers merge their own patches is one thing that will help this, because I know when I was doing the 3.4 release, it was sometimes it was a little challenging, and I actually did have to throw patches back to the developer if I couldn't figure out how to merge it. Another challenge is just getting new testers up to speed. I think it can be a little confusing for a new tester, especially if they aren't really familiar with the test suite and haven't really done a release before. So this is always a challenge, and I think having up-to-date documentation and things will really help with this. Okay, so some ideas for process improvements. These aren't really things that are planned, but these are just some ideas that I have and other people have suggested for sort of making the process a little easier and a little better. The first thing is, and actually some of these I stole from other projects, so this one is one of those things, having a separate mailing list for the stable branch patches. This makes it just a little bit easier for everyone to see which patches are being backported, to follow the approval chain, and just for the release manager to have a better way of keeping a record of which patches have been merged and which haven't. So again, this is just an idea, something to think about. I'm not sure if this would really work for LLVM, but it's a possibility to sort of help smooth out the process. Another thing that I think would be useful if we can figure out a way to implement it would be having some way of annotating commits. So if you commit a fix for a bug and you want to have it backported to the stable release branch, maybe you can tag it somehow and we can have a script or a commit hook that automatically merges the patches back, which would make things a lot easier for developers and also for the release manager. The other thing we can improve, I've talked about this a couple times already, but who's merging the patches? I kind of like where we're at now, where the developers can do it. There's pluses and minuses to both sides. Of course, the release manager has a better idea of what the rules are for stable patches, so they can ensure things like the ABI isn't broken, that it's actually a bug and not a huge new feature, things like that. Those are the advantages of having the release manager do the merging. But at the same time, it's a lot of work for the release manager. It's easy for he or she to make mistakes, so that's sort of the downside. And I think going back to things like having the release manager verify that patches can release that patches adhere to all the rules. If we set up automated testing, I think things like ABI compatibility, we can check that. So maybe we can have some sort of other way to verify that besides just having the release manager look at it. So there's sort of another reason why it might be good to continue having the developers merge their own patches. So another really big thing, a really big improvement that I think would be very helpful would to get more automated testing on the release branches. So we already have build bots for the regular branch for lots of different kinds of hardware. So we can start to get build bots for the stable branches. I think it would really help a lot, especially as people merge patches. We can add the ABI checker to it and add some more hardware. And maybe we can have those build bots automatically generating release packages. Things like that could just really help to smooth the process and make it easier to do releases. Another thing is this sort of in the same line of thinking is, if we can have better automation for the testers too, that will help, again, smooth the release process, make it a little easier to do releases. So I don't know exactly the best way to do this. We already have some pretty good scripts for this, but maybe we can distribute BuildBot scripts that people can use and do automated testing that way. So I just threw up some sort of long-term goals that I think would be good for the stable release for people who are involved. So I sort of talked about this before, but I think it'd be really good if developers could get in the habit of merging bug fixes right away to the stable branch. Again, this would really help make sure we get all the fixes. It prevents us from having a big dump at the end of patches to merge in. So I think this would be something that would be really helpful. Build bots for stable branch, of course. Cheaper releases, like if we're doing build bots, we have lots of automated testing, then maybe we can make it really easy to do a release. So maybe just as simple as flipping a switch, having the bots generate packages, and then we can just do a release really easily. And I think this would really be neat. We have a long way to go to get there, but I think that would be really, really cool if we could have the releases be that simple. So other ideas for stable releases, maybe we could try and do a longer lifetime for stable releases. So what we did with 3.4 was we did 3.4.2, 3.5 was coming soon, so we sort of just stopped maintaining the 3.4 branch. But I can see it being useful for the 3.4 branch to continue longer and maybe have a longer lifetime if there's different projects or users who are interested. So that's something that I think is a good goal. I don't know. We'll have to decide as a community if that's something that we really want, but I can see some usefulness there. And also just being able to validate on more targets. So typically most of our testing is done around the x86 and the ARM targets, but it would be really great to include other backends in that, just so we can have a little more confidence when we do a release that we aren't breaking something. I know a lot of the other backends, there's a lot of internal testing that goes on, but still it's a little bit better peace of mind if you can see that green light on the build bot when you do a release, just to know that the release is solid. So if you're interested in helping out with the stable releases, there's lots of things you can do. One thing, you can volunteer to do release testing. We always need release testers, especially if you have some kind of different hardware like PowerPC or any of the other targets. We can update the release documentation. So, like myself, probably something I should be doing, but anyone who's involved in helping with the release or doing a release management things, if you see something wrong, just update the release document. That can go a long way. Also, we have these really great release scripts, but there's still areas to improve them. So again, anyone who's using these scripts and sees a change that they think could be beneficial, that would be good to contribute that back. And the other thing is, this doesn't really require any coding. If you go through the bug tracker and look for some recently closed bugs, if there's a patch attached, ping the release manager, ping the code owner, and just say, hey, look, here's a bug that was fixed. I think this is something, that we can get upstream. So it doesn't really matter what your involvement with a project is, whether you're a coder, whether you're just a user. There's lots of ways that people can help out and help to make the stable releases better. So with that, that's pretty much all I have. If there's any questions, I'd be happy to answer them. And we have a microphone too, so.
So other can come to with a microphone, so future generation.
About the automatic git hook, I don't think that's a good idea, at least not for now, because lots of patches, people commit and break bots and then revert and commit again and revert. So until we have pre-commit build bots that people can actually send patches before committing to make sure everything's green and then doing that, even so, you wouldn't have double the number of build bots. So you still can break things after you commit. So I think even when you have that, it's not a good idea to make a pre-commit. And especially if a merge fails, what do you do? What the git commit? Does it revert your commit to the trunk? Or so it's the kind of thing that it is going to take more time and effort to make it right, and you might never be able to make it right. So maybe just the way we're doing now is like code owner approves, release manager approves, you, developer, go there and merge because you're going to have conflicts. So deal with them yourself.
Okay, yeah, thanks. Yeah, that's a great point. Yeah, thank you. Any other questions?
All right, so I just had a question about the ABI compliance checking, and
Yeah.
what tools are you actually using to do that?
So I had the link up there. I think the tool is called something like ABI Checker.
Okay.
So if you just search for it on Google, you can probably find it. Let me see
Right.
if the name's in the slide.
The one that is in the test suite.
No, I just found it. So here it is. Here it's the ABI Compliance Checker. I just found it online. But is there another one that's better? Or?
Not sure.
Okay.
Yeah, so Sony Computer Entertainment have been developing for the last year a very comprehensive ABI test suite. And we've got a poster here that one of our senior engineers, he's going to be talking about it tomorrow. So, Tom, I do enthusiastically encourage you to check it out.
Okay. Cool. Thanks.
Any more questions?
Thank you. So I guess the 3.5 is a major release, and like 3.5.1 .x is minor release. So what's the current practice or timeline for minor releases?
Well, we don't really, there's nothing really set in stone. For 3.4, I think we shot to do it around halfway between the 3.4 and 3.5, so that was after 3 months. So that seemed to work out well, but it's sort of an evolving process. So we're happy to get feedback from people what they think is a good length between the regular release and between a stable release. But I think for the last one, we shot to do it right at about 3 months after the release.
So it's kind of a follow-on on that. Sounds like you're going to do one patch release on each major release and then give it up. Have you gotten feedback from the consumers about whether that's long enough? It strikes me as it's probably not.
Yeah, I mean, I haven't really gotten a lot of feedback. I think if there's someone who really needs it longer, that would be a good opportunity for them to, contribute and maybe even help with the release process, because, everyone's always has limited resources. So at some point as a project, we have to move on. It would be great, like I said in my goals, it'd be great if we could extend these stable releases, longer term. But it really just comes down to having the resources and really having someone in the community or enough people in the community who are interested to keep it going. So yeah, I agree that would be very useful if we could keep it going for longer.
One of the uses for that is distributions, right? And we were talking to the Debian and the Ubuntu release for LLVM, and they should be the same, but they're not, because they have different goals and they have different release cycles and everything. The problem is Debian is doing it right. Sylvester is doing a good job of that. But the Ubuntu side, they really don't care. So the LLVM 3.4 in the Ubuntu release now is not even a 3.4 release. It's a random SVN commit before the release because, well, it's when he got it, right? And there's a 3.5, which is actually not 3.5, it's 3.6, but he's called it 3.5. So the thing is, these guys, they have this stable release, long-term stable release, and they need that kind of thing. That was the GCC 4.9 thing, is why do you put the GCC 4.9 in the 3.4.2 if the 3.5 was coming out? Is because I think it was FreeBSD and the Debian, something that they had to be, they were going to base everything on the 3.4, and they needed that because that will be like 3 years on, and they're probably going to use the GCC 4.9. So these are the guys that have to tell us what they need, so then we can do whatever they need to make it happen. But without their needs, we have no idea what they want. So we just do things, and if nobody complains, it's good.
Yeah.
Okay. Any more comments? Questions? If not, then let's thank the speaker again.
Great. Okay, yep, thanks everybody.